This video demonstrates how wind turbines can be modeled and analyzed in AquaSim. Wind power is one of the world's fastest growing energy sources. Wind turbines are one method of exploiting the energy that wind provides. Simply put, a wind turbine system consists of three main components: blades, generator, and tower. When this video is finished, you should have insights to how to model wind turbines in AquaSim, basic concepts of wind turbines, and how to run a dynamic analysis with a wind turbine. To establish a turbine, an automatic generator may be utilized in AquaEdit. And to do so, you need to generate it on an existing element from the 3D window. Therefore, we will start with modeling a vertical beam called tower. The tower supports the turbine structure and is the component connecting the turbine with the foundation. Let us open the Edit Beam window and insert some cross-sectional data for the tower. We select Tube from the Data Source drop-down menu and insert some values. We select OK when we are finished. The beam should be 120 meters in height. And we start from the top and model the beam down to z equals 0. In this example, we are only interested to present the basics of turbine input. The two nodes representing the beam is therefore restrained in all degrees of freedom. To generate the turbine, we click on the beam element in the 3D window and select Elements, Other, Create Turbine on Element. The interface of the built-in Generate Turbine tool will be loaded. In this window, there is currently no turbine generated. This is seen as there are no numbers defined here. The blade sections area is also empty. Turbines can be introduced manually or imported from a file. Once a new turbine is built, this can be exported to the AquaSim library. In this way, generating will be a one-time event. To import an existing turbine, click on Load from Library in the lower left corner of the window. In the folder named Turbine, we find the XML file windmore12mw. This file is included with your AquaSim installation as an example. Having selected Open, the data from this file will be loaded into the Generate Turbine tool. This window can be split into three sections. The top menu with these general settings, called Turbine Information. The blade sections. And the lower part with options for import, preview, generate and so on. Let us start at the top. Number of blades. This is the number of turbine blades that is distributed around the nave. Usually, 3 blades are applied. This can be illustrated with this figure, where the input 3 will result in 3 blades. System yaw gives the orientation for the nave and the system as a whole. 0 degrees means that the nave is pointing along the positive x-axis. 90 degrees mean the nave is pointing along the positive y-axis. Quick start velocity. This is the velocity of the blades and generator upon start of the analysis. The input is in rounds per minute. When the dynamic part of the AquaSim analysis starts, the turbine blades will have this rotational velocity. We leave this equal to +7 rounds per minute. The wind velocity indicator provides 2 choices. The first is named wind distribution, and the other is nominal constant wind. Wind distribution is wind flow that is predicted by a wind profile. The other is nominal constant wind. This is wind flow that can be considered flat, or constant as space. We select the nominal constant wind. Let us move on to the area for blade sections. Here you have columns that specifies a segment length, pre-bend, twist, and library. Each turbine blade is divided into a finite number of segments. To illustrate this, we have a close-up of the turbine blades here. This blade here is divided into entities with a final length. This is called a segment in AquaSim. Each segment has its own color. It is the length, bending and rotation of these that regulated in the blade sections part. The library column points to the folder where the cross-sectional properties of each segment is stored. The lower part of the window gives you options to load turbine for library, as we already have done. You may also save to library, add or remove rows and so on. Let us generate the imported turbine by selecting Generate. We have now a full worthy model. In the Components window we have all the blade segments, 18 in total. Enter the edit beam window for one of the segments. The blade is modeled as a regular Morrison submerged element. Moving to the advanced section, we see that we have a table for drag, lift and yaw for the individual cross-section. By selecting plot, we can see how the coefficients are distributed around the blade, from -180 degrees to +180 degrees. Then we have the nave inner, and nave outer. These are elements that connects the tower to the generator. The generator is found as a node decorator here, and is called shaft hinge. This is a regular hinge that allows rotation about the nave's length axis. This enables the blades to rotate. An offloaded spring is added in the intersection point between the blades. The purpose of this spring is to stabilize the turbine blades in the initial part of the analysis. When the dynamic part of the analysis starts, the effect of the spring is removed. The turbine here gives you access to the Generate Turbine tool. We should run a dynamic analysis with wind to demonstrate how this can be done, and the results options that is found in the post-processing tool AquaView. Select Export from the top menu in AquaEdit. This opens the window where load conditions and analysis settings are defined. Navigate to the tab Normal. Regular wind of 8 meters per second along X direction is applied. Set Num steps for waves equal to 400. When we have 20 steps for one wave, and a period of 1 second, the result in an analysis that lasts for 20 seconds. This should be sufficient to see the blades rotate about 1.5 times about the nave. Select Export, to export the model and analysis. This analysis should take about 2 to 3 minutes to complete. Once the analysis is finished, you can load the AVZ file in AquaView. AVZ files contain results from the analysis. Results specially reported for wind turbines are found from the top menu bar. Turbine Environment. Or Turbine Results. We should investigate some of the options found under Turbine Results. Let us start with nave spin. Right-click on an element to see results as a function of analysis steps. During the analysis, the nave spin stabilizes around 6.65 rpm. Start the playback to see how the blades rotate. Another parameter that is interesting is the calculated torque. This is also found under Turbine Results. The torque shows the same trend as the velocity, it stabilizes around a certain level. In our analysis setup we chose a wind velocity profile that was flat and constant both in time and in space. So, the trend in the result plots correspond well with this. Options found under Turbine Environment are useful to check when validating your model and input parameters. Further details here are found in the AquaView user manual. This is the end of this case study. Remember to visit our webpage aquasim.no for more tutorials and training courses.